Welcome to the Carnivore Cast, the podcast focused on the carnivore diet and lifestyle, with practical advice from successful carnivores, citizen scientists, and top researchers. I'm your host, Scott Meslinski, and I'm here to speak with experts and experienced carnivores to get answers to your biggest and meatiest questions while helping you live your best life as a carnivore. This episode is brought to you by the Carnivore Bar. It's an ancestrally inspired meal replacement bar with real clean ingredients. Zero carb, high fat, just meat. It's only made of beef, tallow, and salt. And for crazy carnivores who don't eat salt, you can also get them unsalted. It's shelf stable and it's portable and convenient. These are great for long hikes, business trips, traveling, or just having an easy, ready option in your pantry. I have them at least once a week and they're delicious. You can use Carnivore Cast, all one word, at carnivorebar.com to get a discount. They're the perfect combination of crunchy and creamy. And as they say on their website, while we do not believe that honey is part of the true carnivore diet, we do support it as a wholesome food choice, especially for our animal-based and paleo dieters. I don't have an opinion on that, but you can get a honey flavor too. Check them out at carnivorebar.com and use code CarnivoreCast. Dr. Miki Ben-Dor is a paleoanthropologist at Tel Aviv University, studying the causal relationship between Paleolithic nutrition and human evolution. Welcome to the show, Dr. Ben-Dor.
Thank you very much. Glad to be here.
Yeah, and I first met you and saw you speak at the Colorado Carnivore Conference. I can't remember if that was 2017, 2018, but
19, I believe.
2019. Yeah. Okay, you gave a fascinating talk about animal sizes and what they can tell us about nutrition. But right. I wanted to and I'm sure we'll get to that today, but I wanted to start at a more basic level. How did humans evolve and how does it compare to other omnivorous mammals?
Okay. Species evolve because the environment changes and they have to adapt to a new environment. This is evolution in a nutshell. And the belief is that humans started to evolve about 6 million years ago when they went off the trees and became more terrestrial. Gradually, of course, and they became more terrestrial because there were opportunities in a changing environment in Africa. It became less woody, less forested. So, and that process continued of drying in Africa, and savannas opened. And in the savanna, what happens is that the biomass of animals becomes higher, and the biomass of plants becomes lower. And really, all the grass we are unable to consume. So we started consuming the animals that could consume the grass, the herbivores, and became, hunters. So this is more or less the story of the evolution of humans until about Homo erectus. Homo erectus appeared in Africa about 1.9 million years ago. And at that time, it is my belief, or my conclusion, let's say, that he was a fully fledged carnivore.
Interesting. And how did you come to become a paleoanthropologist? Tell me a little bit more about your background.
I retired from work at about 52, the age of 52. And I loved the hunter-gatherers since I was maybe 20 years old or so. I really loved they were like the noble savage in my mind, living free, roaming freely in small groups in nature, and I believe that we are hunter-gatherers in our genes, and we are stuck here in an environment that's completely different than the one that we have adapted to. So I said, let's learn a little bit more about these hunter-gatherers, and I found an opportunity to do that at Tel Aviv University here, at the prehistory department of the archaeology section, or actually the prehistory section of the archaeology department. And then I decided after a while to do a PhD so that I can, at that time I already started to understand what is the consequences of the mismatch between our genetic composition and modern nutrition. So I decided that this will be my corner, and this is where I could contribute more to understanding the importance of being aware to this mismatch and to deal with it. So I decided that I better become a PhD and do it professionally and get the recognition that comes with a PhD. So that's what I did. I did a PhD in paleoanthropology, specializing in reconstruction of the human diet.
Fascinating. Yeah, it's cool how you've kind of reinvented yourself in a second career. That's awesome.
Yeah.
And can you talk about some of the traits we evolved as humans that make us more carnivorous?
Yes. So I think the most important one, well, not important, but the most visible one, although we can't see it, but it's easily visible, is the structure of our gut. And this is, it's not my findings. I mean, I didn't find it myself. I just read about it. But I calculated the difference between the gut of chimpanzees that are not really our ancestors, but let's say we had a common ancestor. So this is the gut of primate that eats fruits and leaves. And we have, I've calculated, we have like a 77% shorter large intestines, which is used in the digestion of fiber. Yeah, it's really like a container for microbes to digest fiber. So our evolution was away from fiber, for sure, because our large intestines shrank. On the other hand, the small intestines, which is where fat and protein and sugar get absorbed, were extended by about 66%. So this is the direction of our evolution, for sure, is to consume more of the fat and protein and less of the fiber. So this is one of the main, I think, differences that can be seen. There are quite a few, actually. Another one that's that I found quite impressive is the high acidity of our stomach. So it turns out that omnivore have an acidity of around 4. Carnivore pH of 4. So it's acid, and the water is 7. So it's quite acid. The lower the pH, the more acidic It is. So carnivores have around 2.2 pH. We have a pH of 1.5, which is really a pH of scavengers, because the pH helps fighting the pathogens in the food. So herbivores, for instance, have close to 7. They don't need, because there are not many pathogens on the grass that they eat. But scavengers needed very high acidity, and this is very expensive to maintain. Not only to produce the acid, which is expensive, energetically speaking, but also the container. So the stomach should have a lining that can stand this acidic environment. So we're constantly producing, the lining is constantly produced again and again, just so it can withstand this 1.5 pH. And the author of the paper wrote, it seems that humans were scavengers. But really, he doesn't know much about how humans used to consume meat. And humans are quite unique in carnivores, in that they take the meat and they guard it in a central place. They bring it home. Lions go to the kill. And so most other predators, especially social predators. But we take the kill to the group. So we can consume it for a long time and we sit on it. Just by the way, finished writing a paper claiming that the fire was mainly used, at least in the beginning, to protect against predators and not for cooking, because the return on investment in the protection against predator was about 10 times that of cooking. So that's why we need, because we used to hunt large animals, and large animals you can consume. Let's say if you hunt a buffalo, for instance, you can consume it over a week at least. For a group of 20, 30 people can live on it for about a week. So it will rot, or they dry it, etc. But still, the pathogen load is quite high. So we need the acidity. And there's no way that we would have that acidity if we didn't need it. That's another. There are quite a few others. For instance, one interesting one that you wouldn't expect is the number of fat cells in the body. So if you want to hold a certain quantity of fat, omnivores will have less cells, but bigger cells. To hold the same quantity, predators will have smaller cells, but a larger number of cells. And we are with the predators. It has to do with insulin resistance, etc. I don't even know how to follow the explanation, but this is the explanation. So this and quite a few others we have published together with Rafael Sertoli and Ran Barkai. We published a paper that has 25 different pieces of evidence like this, and 15 of them from biology, and the rest from other fields like paleontology and zoology, etc. And they all really point out to the fact that we were carnivores. And if you want to use an analogy to today's carnivores, all the carnivores today that hunt large animals like we used to do, are what they call hypercarnivores. In other words, they consume more than 70% of their calories from meat. So I would say that this is a good analogy for us. We did eat plants. There's no argument about it at all. There's enough evidence for that. But the archaeology cannot tell us how much we ate. The only method that exists, this is stable isotopes, actually proof that we were carnivores. Just 2 days ago, I saw a new paper about the stable isotopes of late Paleolithic, so about 7,000 years ago, from Sicily. Now, Sicily is in the north, so in the summer, in the winter, there are plants there. It's not like in the north, where in the winter everything is covered with snow and no plants are available. So it makes sense that humans would eat mainly meat. But in Sicily, actually, people in the Mesolithic ate meat, all of them, all the people that they found there, they could study. But people in the Neolithic is the beginning of agriculture, they ate a mixed diet. So that's the
interesting. And you talked a bit about like this, the size of animals we hunted. What types of prey did we hunt, and how did it change over time? And what does that mean?
Herbivores, mega herbivores. The biggest one are elephants, and then rhinos and hippos. The reason we prefer to hunt mega herbivores is because they don't escape. So, energetically speaking, you need a lot of courage to hunt a large animal, but they don't escape. And when they don't escape, if we gather enough people around them, they can be subdued. So, for instance, elephants, you hunt by digging a pit on their way to the water. They usually walk in the same way every afternoon to the water. So you dig a pit, you cover it with leaves, and this is one method. There are quite a few, but it doesn't demand a lot of energy. Once the animals get smaller, they run faster and they actually escape. This is their way of protection. So they are more difficult to hunt. So we tried to hunt the larger herbivores.
Thanks to Biooptimizers for sponsoring the show, and I'm really excited to tell you guys about an excellent deal they're offering this November. This is the biggest blowout deal they will be offering all year, so if there's a time to stock up, it is now. What they're offering is over $200 worth of free gifts and a huge discount all month long on their Magnesium Breakthrough product. Their Magnesium Breakthrough is a full spectrum magnesium supplement that includes 7 unique forms of magnesium for stress relief, better sleep, and mental health, all in one bottle. They're offering all sorts of awesome free gifts and products worth over $200 with select purchases. All month long, they're offering 10% off using my unique code. And you can only get this exclusive deal through my link, special for you listeners. You won't find it on Amazon or even the Biooptimizers website. Go to magnesiumbreakthrough.com/carnivore and use code carnivore to get your discount and free gifts today. Thanks so much and have a great day.
You've talked about humans being fat hunters before. What evidence is there for that? Like, why is it clear that we preferred fat or fatty animals?
The reason, first of all, the reason for hunting fatty animals is that we cannot digest or assimilate more than 35% of our energy, 40% maximum, are from protein. So we have 65% of the energy that we need to consume from either carbohydrates or from fat. So now, since you kill an animal already, it's much more efficient if it had enough fat, so that you don't have to go look for carbohydrates, large quantities of carbohydrates, which the return on them is about 1/10 the return on hunting. So we looked for large animals. Large animals contain more fat, relatively speaking. Of course, they also contain a lot of fat, but relatively speaking, large animals contain more fat. One of the reasons is that they don't escape, so they don't need to be light to escape. So they can afford to have more, more fat for bad days, when there's no food available. This is, by the way, why I think we have more fat also, because we don't escape. There's no chance for us to escape a lion or a wolf. So we don't escape. We protect ourselves in different ways. So we can afford to have more fat. The other type of animal that have more fat normally is what's called prime adults. So these are 2 or 3 years old, 4, 5, 6 years old animals that finish growing. So when you grow, you use most of the reserves to grow. So you don't have a lot of reserves. But when you finish growing, you can have the reserves to secure your survival. And so humans used to concentrate on hunting prime adults. Now, if you think about it, for a predator, this is a stupid strategy, because prime adults run faster, they are more experienced, they're stronger. It's not the type of animal, if you come to a herd, it's not the type of animal that you'll be looking for. And for example, wolves hunt the old and the young because they can chase them. Humans hunt the prime adults. And this is, to me, a proof that they actually aimed at hunting fat. Now, there's a lot of information from recent hunter-gatherers also talking about the importance of fat and how fat is the best thing and how they're always looking for fat. There are tens of examples like that from interviews with hunter-gatherers, and also evidence that when they hunt an animal that doesn't have fat, they just leave it like that. They don't even bother to start taking the meat. So humans needed fat, and this is how they got it.
Interesting. And
yeah, by the way, this is, in my opinion, why they also became smart.
Yeah.
Because you have to hunt the smartest or the most difficult animals to hunt, the prime adults. And what we found is that there was a decline, continuous decline in the size of prey all around the world, actually, but in Africa for sure. And so we had to learn how to hunt smaller prey without losing too much energy. And the way to do it is to develop new hunting tools and the new capabilities of pursuing animals, etc., which demand large brain and other changes, other adaptations.
Interesting. And you had I remember you had this fascinating chart in your talk at the Carnivore conference in Colorado, talking about like depending on the percent of plants versus meat in your diet, like how much protein you should be having, how much protein you can you talk a little bit about that, how you came up with that, and maybe like, is there someplace folks can go see that as well?
The subject of the talk in the carnivore con was how much protein is ideal.
And how did you come up with that scale?
As I said, humans cannot metabolize more than 35%. So I think for 70 kilo, if I remember the numbers correctly, for 70 kilo person, 70 kilo is what, 150? No, 70, yeah. It's about 154, I believe, pounds. I think the quantity is close to 300 grams of protein, if I remember correctly. So this is the maximum that humans can consume, because they have to remove the urea, which is a byproduct of the metabolism of protein to energy, to sugar. And so the chart that you're referring to said that if the plant consumption is, let's say, 10%, so let's say we're talking about 35% from protein, and if the plant consumption has 10% carbohydrates, so we need another, what it would be like 55% fat. Okay, I think this is the chart that you're referring to.
Yeah.
So what the conclusion of this chart was, if I remember correctly, the conclusion of this chart was that we always ate high quantities of protein. So we were more or less at maybe not at the maximum level, but we were quite high, because fat is so difficult to obtain. Really, the real problem is to obtain fat. So I'm pretty sure that from everything I said so far, is that we didn't consume a lot of plants. So that means if fat was difficult to obtain and we did not consume a lot of plants, that we ate quite a lot of protein. That was my conclusion in that presentation.
Yeah, I really like that. I found it really fascinating. And can you talk? You mentioned that there is sufficient evidence that we're also able to use starches and sugar in plants. Can you talk about where that comes from?
Yeah, I mean, look, we came from primates that ate fruit. Now, fruit has sugar, and it has starch, but it doesn't have starch. Fruit doesn't have starch. So starch, there are signs that we evolved to have amylase to turn starch into sugar, right? To glucose. So that's the main proof that we evolved to eat starch. And this happened. Now the question is when this evolution actually happened. And I can't say that we know for sure, but it looks like it happens towards the end just before the agricultural revolution. So we became, but we were always able to digest fruit sugar, right? That's why I also don't believe that a reasonable quantity of fructose will be a big deal. Because we ate fructose, I don't know how much fruit we ate during our evolution, but we came from primates that ate fruit and ate fructose. I think I calculated once that chimpanzee consume about 9% fructose, something like that. Something like 9% of the calories is fructose. Doesn't mean that we can safely do that, but at least it means that it was adapted to consume fructose. I know that today some people are sensitive to fructose, but I personally don't shy away from eating a fruit here and there.
Got it. Yeah, I think that makes a lot of sense. And one thing that's interesting too is aren't the fruits we eat today just so dramatically different than the fruits from Paleolithic times, as well as other?
Oh, of course, there's less starch, and today there's less starch, yes, and more sugar. Sure.
Yeah. What are some things you think we can take away from these perspectives on Paleolithic nutrition and apply it to our own lives?
My conclusion is that the more meat you eat, the better. I mean, the higher the meat and fat percentage, the right fats, yes. The higher that percentage, looked at paleo as a safety template. And I don't know if it's ideal or not ideal. I'm talking about safe. And from my point of view, we were so well adapted to consume meat and fat for 2 million years that today it should be the safest. And what we eat, look, if you bring a hunter-gatherer to a supermarket today, I'm talking, he will not know he will not recognize anything as food apart from the meat.
Yeah, that's great advice.
So for me, this is I'm not, I don't feel myself qualified to talk about specific, other foods like milk and whatever. But I can say that the safest diet is carnivore, for sure, in my opinion.
Yeah. Well, this has been fascinating, Dr. Ben-Dor. Thank you so much for taking the time. Where can folks follow you and some of your work and find out more about what you're doing?
I'm active a little bit on Twitter. So Ben-Dor Miki. And that's the main thing. I have a blog which is not very active, paleostyle.com.
Okay.
And that's it.
Yeah.
And if anybody wants to contact me, you can go via Twitter.
Yeah, I love following you on Twitter. I think you have some great posts, really interesting studies you post up there, great perspectives, and some charts and graphics as well. So I'd highly encourage people to follow you. I'll have links to that in the show notes.
Sure.
Well, thank you so much for your time today, Dr. Ben-Dor. It's been a pleasure and really fascinating talking to you.
Okay, thanks a lot.
If you enjoy the show, please consider supporting the Carnivore Cast on Patreon. By becoming a patron, you'll help us reach more people and continue to create content on carnivore.
There are also exclusive perks available, such as private Q&As, consultations with me, and more. Become a supporter at patreon.com/carnivorecast. Check the episode description for the link. Thank you, and I'll see you there. Thank you for listening to this episode of the Carnivore Cast. If you enjoyed this episode, please review on iTunes. It really helps us out. And share it with a friend. What questions would you like answered? Or who would you like to hear from in the carnivore research community? You can find me on Twitter, Instagram, and Facebook at CarnivoreCast, or go to carnivorecast.com. You can also email me at info@carnivorecast.com. I'd love to hear from you. Until next time, keep it carnivore.